With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello. So question says that which one of the following compound is not aromatic, right? So we have to tell that in which of the following compound is not aromatic, right? So before doing this question, we have to understand that the concept of aromaticity, right? So we have to understand that what do you mean by aromatic and what do you mean by aromaticity, right? What do you mean by aromaticity, right? So you have to understand the concept of aromaticity, right? So for a compound is to be aromatic, right? So it must follow the Huckel rule, right? So there the first condition is that it must follow the Huckel rule, right? So it must follow the Huckel rule, right? Huckel rule, right? So this is Huckel rule, right? And so Huckel rule means that it must have 4n plus 2 pi electron, right? So 4n plus 2 pi electron, right? So this is the must condition for a compound to be aromatic, right? And the second condition is that system must be planar, right? System must be planar, right? Must be planar, right? So, or you can say that all the system, all the center, carbon center has a same hybridization, right? And you can say that, and the third condition is that system has a conjugation, right? System has a conjugation, right? Or you can say the compound has a conjugation, right? So conjugation. So these are the three conditions. If it fulfills the compound condition, right? So the compounds must be aromatic, right? So for a compound to be aromatic, it must have a 4n plus 2 pi electron, right? It must have a 4n plus 2 pi electron. It must have a planar, and it must have a conjugation, right? So these are the three conditions, right? So these are the three conditions, right? If any one of these condition is not or you can say it is not fulfilling, right? So the compound is not aromatic, right? So let's try to solve this question. So if we see the option A, right? If we see the option A, right? So I'm just solving the option A. That means here this is the compound, right? This is a 5-membered ring, right? So this is 5-membered ring, right? So here it is positive charge, right? Here it is positive charge, and here it is double bond, right? Here you can see that all the carbon are here as sp2 hybridized, right? All the carbon are here as sp2 hybridized, right? This carbon is sp2 hybridized, right? And this carbon is also sp2 hybridized. This is also sp2 hybridized. This is also sp2 hybridized. That means it is plain, right? So this is also sp2 hybridized, right? This is also sp2 hybridized, right? And this is also sp2 hybridized, right? Because there is a double bond, and here it is also sp2 hybridized, right? So this means that all the whole system is in plane, right? So it is in plane. That means you can say that all the system is in plane, right? So system is plane, right? So the second condition is fulfilling, right? And you can see this, there is a conjugation in this system, right? So you can see there is a conjugation in this system, right? So that means it has a conjugation also, right? It means it has a conjugation also. You can see right here, right? So if I'm doing like this, so the conjugation will be look like this, right? So you can see easily, right? Here the bond comes here, and positive charge moves here, right? And again here, right? So this is the conjugation, right? This is the conjugation here, right? So you can see very easily, right? And again here you can see here. So this is the conjugation. So the pi electrons move like this, right? So that means these two conditions are fulfilling, right? So now you have to find out in this compound there is any kind of 4n plus 2 pi electron, right? So here you can see that there are 2 pi electrons, right? So there are 2 pi electrons. That means in one pi electron there are 2 electrons, right? So in one bond there is 2 electrons. So how many pi electrons are there? Here are 4 pi electrons, right? So in this compound I can write here as in this compound 4 pi electrons, right? 4 pi electrons are there, right? 4 pi electrons, right? So that means this compound is not fulfilling this condition, right? So it must have a 4n plus 2 electron, right? So 4n plus 2 pi electron, right? So and 4n plus 2 pi electron, that means it has a 6 pi electron, but here it is 4 pi electron. That means the compound is not fulfilling this condition, or you can say that the compound is not following the Huckel rule. That means it should not be aromatic, right? It should not be aromatic. That means I can say this is not aromatic, right? So this is not aromatic, right? This is not aromatic, right? So or you can say that it is anti-aromatic, right? So the compound which is fulfilling the, you can say, which follow the 4 and pi electron, right? So the compound is called anti-aromatic, right? So that compound is called anti-aromatic, right? Anti-aromatic, right? So it is not aromatic, it is anti-aromatic, right? It is just opposite of aromatic, right? It is just opposite of aromatic. That means the compound is very unstable, right? So now let's see the next option. The next option is pyrrole, right? So next option is pyrrole, right? So let's see it. Here it is, the compound is like this. Here nitrogen and here double bond, right? These are electron, right? So here you can see that compound is planar, right? Compound is planar, right? Compound is planar, and here it is also a 4n pi 4n plus 2 pi electron, right? So here there 1, 2, and these lone pairs are involved in the conjugation, right? So you can say that the lone pair which is involved in the conjugation are counted as a pi electrons, right? And the lone pair which is not involved in the conjugation are does not count in the conjugation, right? Or that does not count as a pi electron, right? So here you can see that there are 6 pi electrons, right? So there are 6 pi electrons. That means they follow the 4n plus 2 pi electron, right? So I can write here as 4n plus 2, right? So if I write down this, then 4n plus 2 is equals to 6 pi electron, right? So it is equals to 6 pi electron. That means I can write here as 4n is equal to 6 minus 2, right? So 6 minus 2, right? 6 minus 2. So I can write here as n is equal to 1, right? So I am getting here n is equal to 1. That means it is following the 4n plus 2 pi electron, right? But above here, I am not getting the n, the value of n not equal to 1, 2, 3. I am getting the value of n is in fractions. It is rational form, 1 by something, right? So that's why the above compound is not following the Huckel rule, and this compound is following the Huckel rule. That means it is aromatic in nature. That means it is aromatic in nature, right? That means it is aromatic in nature, right? So I can write here as that this compound is aromatic in nature, right? So if I talk about the compound C, right? So if I talk about the compound C, so the compound C is look like this, right? So it is a pyridine, right? It is a compound that is, we call it pyridine in general form, right? So this is pyridine, right? So this compound also has a 6 pi electron, right? So this pi electron, right? Here you can see this. There are lone pair also, right? So but this lone pair is not involved in the conjugation, right? So that's why we do not count it as a lone pi electron, right? So here are 3 pi electrons, right? Here are three pi electrons, and that means 3 bond. That means total 6 pi electron. That means this compound is also aromatic. This compound is also aromatic, right? Right? And if I talk about the option D, right? If I talk about the option D, that is this compound, right? This compound, right? Here it is also negative ion, right? And there is double bond, right? But this compound is, this lone pair is involved in conjugation. That means all the compound is planar, right? The compound is planar, and this is you can say that there is a conjugation also, right? And there is also a 6 pi electron, right? So this negative charge is acting as a involved in the conjugation. That means it is counted as a pi electron, right? So there are 6 pi electrons. There are 6 pi electrons, right? So the 6 pi, there's one bond here, right? So one bond here, and there's a one negative charge here, right? So total there are 6 pi electron, right? So this compound is also aromatic, right? So this compound is also aromatic, right? So but in the question it is asked that which of the following compound is not aromatic, right? Which of the following compound is not aromatic, right? So here we see that the option B, that means pyrrole, pyridine, and this anion, cyclopentane anion, right? So this is all the compound B, C, and D are aromatic in nature, right? So you can see here clearly that all the compounds B, C, and D are aromatic in nature, right? The compound A, that means this compound is not aromatic, right? So you can say it is anti-aromatic because it is following the rule 4n pi electron. It is not following the rule 4n plus 2 pi electron. That means it is violating the Huckel rule, right? So in this way, I can say that our correct answer will be option A, right? Our correct answer will be option A. That is, this compound is not aromatic, right? So and rest of the compound is aromatic, right? Rest of the compound is aromatic, right? So option, I can say that option B becomes wrong, option C becomes wrong, and option D becomes wrong, right? So our correct answer is option A, that is the non-aromatic compound, not aromatic compound, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.